Okay friends, so tutorial 8 and 9 I already shared with you uh, on our blog, so you can download that and you can go through the problems. I have discussed almost all problem except one which was very similar. So I in this presentation, in this video, I have discussed various problems in tutorial 8 and 9, and I think it will help you to solve them. uh, Bearing one or two problem, I have not given any numerical values in this, but I think the pointers which I will be giving you here will help you to solve the problems. And if you encounter any issues, you can always contact me. See, the first problem for tutorial 8 is it is for designing a distillation column for separating 1-chlorobutane and chlorobenzene. We need to generate pxy data at 50 degrees Celsius. Minimum 7 data points are given. Vapor pressure equations are given like Ln P1 set A minus B over T plus C, and same way for component 2, which is chlorobenzene. PI sets are in kilopascal, temperature in degrees Celsius. And it is said that the system is non-ideal and is well represented by activity coefficient model as Ln gamma 1 is Ax2 square and Ln gamma 2 is Ax1 square, with A being 1.23. The process for generating pxy data is very similar to your ideal system. Only changes because it's a non-ideal system. We need to calculate gamma, and we need to take into considerations the value of gamma for calculating pressure. Now we know that bubble point pressure for non-ideal system can be given by this equation, which is nothing but x1 gamma 1 p1 set plus x2 gamma 2 p2 set. Temperature is fixed, that is 50 degrees Celsius, so you can calculate P1 set and P2 set, which are fixed values. Once you get P1 set and P2 set, what will you do is you will list various values of X. Once you get various values of X, you can calculate gamma corresponding to that. So we fix temperature and X, and for each value of X we calculate gamma 1, gamma 2, and correspondingly vapor bubble point pressure, and then using equation YIP is xi gamma I P set, you can calculate y1, and if required y2, because once you know gamma 1, gamma 2, pressure, and Pi set, you can calculate y. So if we call this as equation 1 and 2, we can generate the table like this, where x1 we start with 0 to 1. However, here there are not 7 points, you can make 7 points. So for x1 0, gamma 1 is exponential a, x1 0, so x2 is 1, gamma 2 1. You can calculate p equals to P2 set here, which can be obtained from equation 1, and y1 can be obtained by manipulating this as x1 gamma and Pn set upon P. Likewise, you take different values of x, you generate different gamma 1, gamma 2, calculate bubble point pressure using this, and then y1. And you can make this as a table, or you can separately write P x1 gamma, P x1 y1 as your table. So that's your first problem, which is this. Next problem is an experimental determination of the VLE state for the ethanol toluene system gave the following results, where vapor pressures are given at 45 degrees Celsius for ethanol and toluene. X1 is given 0.3, Y1 is given 0.634, and total pressure is given. So this entire values like temperature corresponding to 45, pressure corresponding to 183 mmHg, x1 0.3 and y1 0.634, this constitutes one VLE data. Now in this problem I have given you a pointer like calculate liquid phase activity coefficient, which means that the system may or may not be ideal. If this both the activity coefficient values which we calculate comes out to be 1, we say that the system is ideal. If not, we say that the system is non-ideal. However, in this case we can also see that your vapor pressures are 75 and 173, and since the total pressure given, which is 183, which is more than this two, we can directly say that the system is non-ideal. So if the part 1 is not asked here, like calculate liquid phase activity coefficient directly asked, the second part where it is said that what pressure would be exerted by the mixture having liquid composition 0.5 at 45. In that case, what you need to do is you need to first identify whether the system is ideal or not. How do you check that? You need to check it by using this equation. Now if I say that in this equation y1 is given, p is given, x1 is given, and p1 set is given. If y1 p is equal to x1 p1 set is being satisfied, that means if gamma 1 is unity, we say that the system is ideal. If this is not satisfied, we have to calculate gamma 1, Same way, using y2, x2, p2 set and p, we need to calculate y2. So y2 would like gamma 2, that is y2p upon x1 p1 set. Once we get the value of gamma 1 and gamma 2, we know that the mathematical expressions for gamma 1 and gamma 2 are this. Now I know gamma 1 from this value at x2 equal to 0.7 and gamma 2 from this equation at x1 equal to 0.3. This can be then further written as ln gamma 1 minus ln gamma 2 is equal to ax2 square minus ax1 square. Now I know gamma 1, I know gamma 2 from this equation, I know x1, x2, only unknown in this equation is a. I can solve for a and I can get the value of a. Once I get the value of a, then the second part becomes evident. What happens is now I need to calculate, I have been given T and x1 for non-ideal system for which A is given, temperature is given, vapor pressures are given, and what I need to do is I just have to use bubble P calculation for non-ideal system at 45 degrees Celsius and x1 equal to 0.5 to get the pressure and if required Y. So this is how you can solve the first two problems. So I think first two problems I think are clear. In next video we'll discuss about the remaining problems.